Okay, let's talk about the Double Dabble algorithm. Also called the shift and add 3 algorithm. So what does this algorithm do? This algorithm takes a binary number and converts it to a binary coded decimal number. So what's a binary coded decimal number? Let's use the number 123 as an example. In decimal, the first digit is the ones digit, the second digit is the tens digit, third digit is the hundreds digit. If we were to take this 123 and convert each digit into its own 4-bit binary number, it would look something like this. 0001 for 1, 0010 for 2, and 0011 for 3. Now, what would this look like in binary? Well, let's say we have an 8-bit binary number. We know the most significant digit would be the 128th place. Next, 64, 32, 16, 8, 4, 2, the ones place. If we want to make the decimal number 123, it would be 64 plus 32 plus 16 plus 8 plus 2 plus 1. So how do we get this number, turn it in to this number? Well, to do that, we're going to use the Double Dabble algorithm. Alright, so the first step to the Double Dabble algorithm is to create a working variable that's long enough to hold your original number and the binary decoded decimal number. So let's write that down. Step 1. Create working variable long enough to hold the original number and the binary decoded decimal number. So what does that mean? If we scroll back up and we look at our original number, we'll see that it is 1, 2, 3, 4, 5, 6, 7, 8 digits long. And our binary decoded decimal number is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 digits long. So 8 plus 12 would be 20, so we need a 20-digit long number. So let's do that. Let's create a 20-digit long number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Alright. So what do we do next? We partition off this number into 4-bit numbers to hold the binary decoded decimal values. So these first 4 spaces will correspond to hundreds place. The next 4 correspond to the tens place. And the last 4 will correspond to the ones place. So let's redraw these lines to make more sense. So these ones place, next 4 here will be the tens place. These last 4 will be the 100ths place. So before, when we had our binary decoded decimal, that looked like this. 1, 2, 3. So that's what we're going for. All right, let's erase that. That's our end goal. All right, then we take our original number here and we place it in the least significant bits of this working variable. So that would be 0, 1, 1, 1, 1, 0, 1, 1. Okay. This is the working, or so excuse me, this is the original number. Let's get rid of this line so that we can differentiate more easily our number from our working variable. Let's change the color of it. There we go. So here's the hundreds place, tens place, ones place, and then, let's see, I've missed one. Our original number. Okay. All right. So that's step 1. We've created that. Now step 2 is to create a counter. Create a counter. That counts. From length of our original number. That's this number right here, our original number. Let's see how many digits that is. That's 1, 2, 3, 4, 5, 6, 7, 8 digits. So in our case it'll be 8. And it counts down from that number down to 0. All right. So we'll say counter, and we'll give that a value of 8 right now. Okay. So those are our initialization steps. Step 3 begins the actual algorithm. So we're going to shift our working variable, which is everything highlighted in blue up there, left by 1. And when we do that shift, we're going to pad it with zeros. So let's do that real quick. Let's shift everything in this original number. Let's make a copy. Let's paste it. All right. Let's actually drag it down here. Makes more sense down here. Let's take this number and let's shift it over by 1. Let's get rid of this blue line, make it a little easier to shift. And we're going to shift all these numbers over by 1. That means if this is the end and this is the beginning, the 0 is shifted into oblivion. It's gone. This 0 is shifted here. This 0 is shifted here. This one here, so on so forth, all zeros, till we get here. So this 0 was shifted there. Now this 1 is shifted here. 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 0 here. 1 here. 1 here. And now in this last spot, what happens is we shift in a 0. Alright, so everything's been shifted over 1. If we go back and look at our binary decoded decimal digit spaces, we still don't have anything in there, which is fine. But our original number has now been shifted over by 1. Alright, which brings us to step 4. Step 4 is to check each BCD digit, that's this one, and this one, to see if their value is greater than 4. And if we look, we see that the first one is all zeros, second one all zeros, third one all zeros. So it's not. But if any are greater than 4, we add 3 to that digit only. And you'll see what I mean here in a few iterations of this. All right, and so now we're on to the last step. Step 5. Here, we check to see if our count is 0 yet. And I should mention, back in step 3, we forgot something. Okay, step 3, after you've shifted, subtract 1 from your count variable. All right, we forgot to do that. So let's go ahead and do that now. So now we're at 7. All right, so that relates to step 5. Check to see if your count is 0 yet. It's not, it's 7. So what do? If it isn't 0, go to step 4. All right, where's step 4? Oh, excuse me. Go to step 3. Step 3 is our shift step, right? And if it is 0, you're done. It's the end of the algorithm. You should have a binary decoded decimal number in these most significant bits up here. All right, so it wasn't 0, so let's go to step 3. All right, let's get rid of this old number that we shifted, and let's move this number up, and we'll shift again. All right, so let's go ahead and erase all this to make it easier for us to see what we're doing. All right, and we're going to shift it one more time. All right, so here's the end, here's the beginning. This 0 is shifted into oblivion. This 0 is shifted over, 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 so on, so forth, till we get to this 1. Now magic is actually starting to happen. 1, 0, 1, 1, 0. And then again, we move a 0 in to that last spot. And then we can't forget, like we did last time, we need to subtract 1 from our counter. So now our counter is 6. Alright, so what do we do? Let's go to step 4. Check each BCD digit, see if their value is greater than 4. Alright, let's highlight those digits again. So it's the hundreds, tens, ones. None of these are greater than 4. The hundreds are still 0, tens are still 0, but the ones are now equal to 1. Alright, but none of them are greater than 4, so we go back to 5, check to see if it counts 0 yet. It's not, so we jump back up to step 3. So we do this all over again. Alright, so let's get rid of these. Make this the new count, move it up. Alright, get ready to shift all these numbers again. Alright. So let's shift that into oblivion. 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. This gets to be a 1. This gets to be 1, 1, 1, 0, 1, 1, 0, 0, and then we insert that next 0 in. Alright, let's section off our BCD digits, see if any of them are greater than 4. And it doesn't look like it. Our hundreds are still 0, our tens are still 0, but our ones now are equal to 3. So we're making progress. Alright, subtract 1 from our count. Count is now 5. And we start back all over again. So let's delete the last one. Let's move this one up. And do the shifting process all over again. Alright. Off you go. So it goes here, 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 here. 1, 1, 1, 1, 1, 1, 0. And then we insert in that final 0. Alright, now let's evaluate this. Subtract 1 from our counter. And evaluate to see if these digits, any of them, are greater than 4. And look at that. The ones place is now equal to 4 plus 2 plus 1, 7. Alright, so we add 3. So 7 plus 3 is 10. We represent that in binary. Let's go ahead, delete these values because we just added 3 to them. So now they're 10, so that's 8, 9, 10. Alright, so that's our new number. Right? We check to see if our count is 0. It's not, it's 4. So we jump back to step 3. Let's go ahead and delete the old number. Get this new number. Let's move it up. Start shifting again. Alright. Shift that one out. 0, 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, 1, 0, 1, 1, 0, 0. And we insert that last 0. Alright, subtract 1 from our counter. We're at 3 now. Now we want to check each BC digit to see if their value is greater than 4. Alright, so let's do that again. Hundreds still 0. Now we got something interesting happening in the tens. We got a 1. Still though, that's not greater than 4. So we go ahead and we check the ones. What's the ones? The ones is 4 plus 1, which is 5. Oh man, we got 5. So what are we going to do? We're going to add 3 to it. How do we represent 8 in binary? That one's easy. It's just a 1 here. All right. Check to see if our count is 0. It's not. We move on. We can do the shift all over again. So let's get rid of this guy. Get rid of this stuff. Let's move it up. Start shifting. All right. Goes nothing. Zeros all the way down. Okay, subtract 1. Let's see, check each BC digit. So let's check our digits again. Still nothing in the hundreds. Tens is pretty interesting now. We got 3 in the tens. Right there we have a 3. And in the ones, we got a 0. Okay. So we shifted, so we move this down to 1. Then we pop back up to our loop, shift again. So let's see. Move it up. Shift over. Zeros, and we check. Well, drop that down to 0. Check. C. Alright, that should be there. Check to see what our number is. Alright, so we've still got nothing in the hundreds. Now though, we have 6 in the tens place and 1 in the ones place. So we check. 6 is greater than 4, so we're going to need to add 3 to that. So that'll be 9. How do we represent 9 in binary? That's easy too. That's 8 plus 1 is 9. Alright, 1 doesn't need to change. So what do? Check to see if our number is 0 yet. It's not. Pop back up to 3. And we do this all over again. Delete all these guys. Delete this. Shift. Let's add this. Shift it up. Start shifting. So it goes away. Are zeros. All right. Subtract 1, 0. Somewhere along the way, I think we counted 1 too many times. We should be at 0 now, though. Let's see. All right. So the next step is we check to see what our binary coded decimal number is. We got a 1 in the hundreds spot. We've got a 1 in the twos spot. And we've got 3 in the 1 spot. So 123 is the number we were originally trying to get to, as you can see. We go down, check see if our number is 0 yet. It is. And we're done.